Hey guys, let's analyze some graphs today. What do you think? Polynomial functions, let's analyze some. Here we go. First of all, we've talked about this throughout the year. When you see the word zeros, zero is what makes the polynomial equal zero. A factor, x minus k solution, x-intercept, they're all the same thing. The only thing different is a factor. Let's say that 2 is a zero of that polynomial up there. It means it's also a solution. It also means it crosses the graph. If you were to graph that, it would cross the x-axis at 2. Those three things are exactly the same. Now, when it says it's also a factor, it means x minus 2 is a factor. Okay, so 0, solution, x-intercepts, all the same thing, and you can write it as a factor just by doing that right there. So we've talked about that before. Just a quick reminder. Okay, so we're going to graph some today. By using zeros. We're just going to rough sketches. Not going to do exact graphs, just pretty rough sketches. So first of all, one of the factors is x plus 3, which means one of the zeros is -3. A 0 is an x-intercept. One of the zeros is a 2. It's an x-intercept. Now, remember we talked about before, because that's an even power right there, that means it's going to bounce off of that 0. Now, there's 3 total x's. That's x to the first power. That's x squared. That means there's 3 x's, which means it's odd. The 1, 6 is positive, so it's going to go down to the left, and it's going to go up to the right. So when I draw my graph over here, it's going to go down to the left, cross at the -3, come back down, bounce off the 2, and go back up. And we're not going to worry today about how far up it's going or anything like that, just a general sketch based on what the zeros are. Okay, one thing, a new concept we're going to talk about is how do you find all the real zeros? Okay, so we've talked about making a list, graph on your calculator. This is another way. This is a table function. And some of this video, I'm going to have to really show you in class tomorrow because a lot of it's on a calculator. There's a button on your calculator. If you look right above your graph button, it says table. And so what I did is I punched this in to y equals, hit table, and it gives me these numbers. And here's what I need you to do here. Notice it goes from negative to positive right there between 1 and 2. What that means is there's a 0, obviously, between negative numbers and positive number, which means there's a 0 of that function or a solution of that function or an x-intercept of that function in between 1 and 2. That's what we're trying to get from the table. All right, turning points. Big deal here. The graph of a polynomial function of degree n, whatever the degree is, it can have at most one less than that turning points. So like the graph I'm looking at down here is probably an x cubed, probably a cubic graph, because it can have at most 2 turning points. There's a turning point, there's a turning point. Now the turning points are called maxes and mins, local max, local mins. It also says this, if a polynomial has degree n and has n distinct zeros, the graph has exactly a minus 1 turning point. So this is degree 3. If it has 3 zeros or 3 x-intercepts for sure, it's got to have 2 turning points. The deal, though, is, and it's kind of confusing, and I'll talk about more about this tomorrow, but no matter what the degree is, like if I show you x to the 4th, it can have at most 3 turning points, 3 maxes or mins. If it's x to the 5th, it can have at most 4 turning points. It doesn't mean it has that many. It just means that's the most it can have. All right, it says graph each function, identify the x-intercepts and the points where the local maxes and mins occur, determine the intervals for which is increasing, decreasing. Okay, now I went ahead and showed you a picture of these graphs. The first one is A, and there's a max right here, and we can use the calculators to find those. So I'm going to teach you how to do that tomorrow in class also. So there's the max. There's a 0. It only has 1 0 right there across the x-axis one time, which looks like it's about -1. So we would say the 0 is at -1. There's a max at 0.6. There's also a min right here, and that's just, they didn't show me that on the picture. We'll just kind of guess there and say that's about 2 and 1/2. So where is it increasing? It's increasing as it's rising from left to right. So it's increasing forever until it gets to the max. All right, so it's increasing from -infinity until it gets to 0. Now we just use the x-coordinate. Then it's going to be decreasing from the max, which is 0, until the min, which is at 2. And then it starts increasing again right there. It increases from 2 to forever. All right, and that's how that one works. I'm not going to spend the time to do part B also to make the video too long. But let me draw one thing on part B. There's the decreasing section. There's the decreasing section. It's as you look at it from left to right. And when you describe it, we're going to use the x coordinates only, just the x coords. It's increasing there to there. It's also increasing there to there. So it's got two decreasing parts, two increasing parts, and that's how we're going to write it like we did that first one. All right, even and odd. Two ways to do even and odd. Even functions. First of all, even functions are symmetric with the y-axis. So if you look at this even function right here, I'm circling it. If I were to fold that graph over the y-axis, it'd match up perfectly. It's symmetric. Okay, now an odd function, this one right here, the odd function is symmetric with the origin. What that means, when it says symmetric about the origin, that means if you turn the graph upside down, like if you punch it in your calculator, look at it, turn it upside down, it's gonna look exactly the same. So even, symmetric with the y, odd, symmetric with the origin. Now, one other way you can tell is this. If it's even, you can plug in a negative x anywhere in the function and you'll get the exact same function you started with. That means it's even. If it's odd, you can plug in a negative x and a negative y, and you will get the exact same thing you started with. I'm going to show you one of each here on the last slide, and we're done. All right, it says determine whether each is even, odd, or neither. One hint is look at your exponents. Now, this is what I'm about to say. If they're odd exponent, if all the exponents are odd, that means it can't be even. It doesn't mean it's odd, it just means it can't be even. So here's how we're going to tell. One way is I could graph it, and I could show you the graph and see if it's the same thing upside down or right side up. I know this is either going to be odd or neither because of the exponents. I know it can't be even. So the way you tell algebraically is you plug in a negative y where the y is, that's the y, and you plug in a negative x everywhere you see an x. Okay, so that would give me a negative y. If you raise a negative to an odd power, it stays negative. That's a negative x times a 7. That's 7x. Now, it's almost the same thing I started with. What I'm going to do, because I started with a positive y, I'm going to make my y positive and just multiply both sides by negative 1. And look what I get. If I multiply everything by negative 1, I get that right there. Now, you got to ask yourself, is that exactly what I started with? Yep. That means it's odd. That's the algebraic way. And again, the graphic way is you punch in your calculator, look at it, turn it upside down. If it looks the same, it's odd. Okay, second one, even, odd, or neither. Now look at the exponents. They're all even, which means it's not odd. All right, that means it's either even or neither, one or the other. Now the algebraic way for even is you plug in a negative x everywhere there's an x. So I'm going to put a negative x there. I'm going to put a negative x there and work that out. Anytime you raise a negative to an even power, it becomes positive. That becomes positive. And now I got to here. You got to ask yourself, is that the same thing I started with? Yep, which means it's even. Okay, another way to do that one is you can punch in your calculator, look at it. Is it symmetric with the y-axis? That one would be. I mean, yeah, the y-axis, it would be. So that means it is even. So one more time, even is symmetric with the y, odd is symmetric with the origin. To find even algebraically, plug in a negative x, see if you get the same thing you started with. If it's odd, plug in a negative x and a negative y, see if you get the same thing you started with, and that's it. All right, guys, that's quite a bit. That's a pretty good video right there. Pretty lot of stuff. We'll work on it in class like we always do. And then we're going to have a Christmas vacation pretty soon. All right, it's the last video before Christmas. See you tomorrow.